Welcome. Our lesson today is dealing with angles and radian measures, and this is our first day. And today we're going to learn how to classify angles, how to find radian measures and degree measures, and how to convert between degrees to radians and radians to degrees. So first, let's talk about how to classify an angle by its angle measurement. Now, if you remember from geometry, there are different types of angles, and I'll just go ahead and write their classifications. We have acute, obtuse, right, and we have the straight angle. And an angle that is obtuse measures between 0 degrees and 90 degrees, not including. So any angle that falls in this range is classified as an acute angle. And whenever you're referring to degrees, make sure you put the degree mark. An obtuse angle measures between, and I forgot the degree mark here, 90 degrees, but it has to be less than 180 degrees. That messed up. Sorry about that. And then, of course, a right angle is equal to 90 degrees. And then a straight angle is equal to 180 degrees. So those are the 4 types of angles that you will cover in this section. So they'll give you the angle measurement, and then depending upon which category it falls, that's how you would classify the angle. Now, angles are also measured in what we call radians. And you're going to see a lot of this in our trig sections. Let me just write the title for you. And so you'll understand what a radian measure is. Let me first draw a circle so you can understand the background of a radian. Okay, you know, in a circle we have a center, and this area, this is our radius, this is a radius, and we're going to call it R. Okay? And right here, this angle right here, because it does make an angle or form an angle with the center of our circle, we call this the central angle. And we use this symbol, looks kind of like this, and this is theta, and this refers to our angle in radians. Okay, so that's that angle right here. And then this region from here to here represents the arc, or the arc length. And we denote that by the letter S. So far we have R, which is your radius. and S, which is your arc length. And let me label this so you'll know. Okay? So, in order to find an angle in radians, which we represent by theta, or we can just say radians for right now, the formula would be S divided by R. And just to recap, remember S represents the length of the arc. And you have to divide that by your radius. Okay, so this is the formula to help you find an angle in radians. And as I said before, radians is just another unit to help you, or another way that we can measure an angle. Because an angle can be measured in radians or degrees. So this is a very important formula that you need to know. I don't like to say memorize, but you do need to know it because you're going to be asked to do this not only in our application problems, but also on your quiz and tests. So let's try an example. Okay, looking at the first example, it says, find the radian measure of the central angle with the radius of 6 inches and a arc length of 15 inches. There should be an arc length of 15 inches. Just going to squeeze this in. Okay. So if you remember our formula, and this is in radians, that's our units. And remember, S represented the arc length. So did they give us the arc length? Why, of course, 15 inches. And then R represented the radius. And they gave us the radius, which was 6 inches. So now that we have everything we need in our formula, we can plug everything in. So we have 15 inches divided by 6 inches. If we notice, our units cancel out. So we're left with, you can either reduce the fraction by dividing both by the numerator and denominator by 3. And you can get 5/2, or you can get the decimal, which is 2.5. Now, you can either write theta equals 2.5, or you can write 2.5 radians. Whatever you do, don't write degrees. Okay? Okay, now I want you to try our checkpoint to see if you really understand how to find the radian measure. So now it says, what is the radian measure of a central angle in a circle with radius of 12 feet that intercepts an arc length of 42 feet? So I want you to pause the video and try this example by yourself. And then we can check our answer. Okay, if you did it correctly, this is what you should have gotten. Notice I'm continuously writing the formula because that helps you to get familiar with it if you see it over and over again. So we have our arc length again, which is 42 feet, and our radius now is 12 feet. So I plug those values in for S and R. And this time, when I divide it, my units canceled out. And I was left with 7 over 2, or 3.5. So now, my central angle, the radian measure, is 3.5, or you can write 3.5 radians. And we want to get in the habit of making sure we either highlight or box our answers so it stands out from the work. So far, we talked about how to define an angle or classify it by its degrees, and then we talked about how to find an angle in radians. But how can we relate the two, and how can we get or obtain a relationship between degrees and radians? So if you think back to a circle, and here's our center, and you think about, and this is R, one rotation around our circle. If you think about that measurement, and then you look at our arc length, which was, remember, S, then we're thinking about the distance around the circle, which we refer to as our circumference. Okay, remember the circumference of a circle is equal to 2 pi r. Okay, and so if you think about what we just learned about how to find how to find the central angle in radians, we can go back to our formula, which is equal to S over R. Well, we have S, which is 2 pi r. We don't know the radian measure, but we know that it's R. And if you notice, our units, our radius, cancel out, and we're left with 2 pi. So that means that one complete rotation measures 2 pi radians. And if you can remember, 2 pi radians, or one complete rotation of a circle, that angle measurement is the same thing as 360 degrees. So 2 pi radians is the same thing as 360 degrees, which means that if I divided both sides by 2, 1 pi radians would equal to 180 degrees. So this conversion is what is going to help us get the relationship or the conversion rule from radians to degrees. So 1 pi radian is equal to, or radians, is equal to 180 degrees. Therefore, anytime you have to go from degrees to radians, you're going to use this formula. So if they ask you to convert degrees to radians, you're going to use this simple conversion, that the degree that they give you, you're going to multiply that by, you're going to use what we just learned, in order for our units to cancel. Actually, we know the degree, which was 180 degrees, we know that equals to 1 pi radians. So this little formula will help you. So you're going to multiply the degrees that is given by pi radians over 180, because that way the degrees will cancel out. So if you don't understand, let me show you in an example. Okay, so we're going to convert this angle in degrees to radians. So my angle is 270 degrees. So following our formula above, we're going to multiply this by 1 pi radians over 180 degrees. And it's very important that you do write the units, because that way you can see that these will cancel. So then you're left with, if you multiply straight across, because we can put this over 1, 270 pi radians divided by 180. Now when you get here, you're going to either divide or reduce the fraction. So if we reduce it and divide them both by 90, you're going to end up with 3 pi over 2 radians. And there you have it. And even if you have a, sometimes you may see a negative. So you may see like negative 135 degrees. You still treat it the same way. And it's okay to have a negative radians degrees. So use our same conversion formula. Oh, no more degree. And sometimes you may have to divide a couple of times before you get it reduced in its lowest term. So after you reduce it, you're going to get negative 3 pi over 4 radians. And there we have it. Now we're going to go from radians to degrees. Okay, to convert from radians to degrees, we're going to use this conversion formula. So we would start with our radians, because that's what's going to be given. And now we want the radian units to cancel. So this would be pi radians. And remember, 1 pi radians equals 180 degrees. That way, your radians measure would cancel. So let's try one here. Okay, let's start with 2 pi over 3 radians. And we're going to convert this to degrees. So we're going to use our formula above. We know that we want to cancel out our units, pi radians. We know that pi radians is equivalent to 180 degrees. Therefore, our pi radian units cancel. And here, show you a trick. You can do what we call cross-canceling. That makes it easier for you all when you are trying to reduce fractions. So I know that 3 will divide into 3 once and 180 60 times. And there we've made it easier to work with. And so now we're left with 2 times 60, which is 120 degrees. And that's over 1. So now we have our degrees. And we're done. And the same thing if it's a negative. Sometimes you will have a negative degree, which means that, which we're going to learn later, that we're going in a different rotation around our circle. Now, I want to caution you if you have something like radians, and not pi radians, just radians, and you went from radians to degrees. For example, if you had 6 radians, and I needed to convert this to degrees, and I know 1 pi radians I don't like the way that it's right this so it looks clear. Okay. Now, be careful, because I know you have a tendency to just cross everything out, but notice only the radians cancel. So we still have pi in our denominator. So we have to do 6 times 180, 180 degrees. So we have 1080 degrees, but we still are dividing that by pi. Okay, so that would be equivalent to, after you put that in your calculator, because you're going to have to put that in your calculator to get the and I'm just going to approximate now. That will be approximately 343.77 degrees. So be careful when you're just converting radians to degrees, not pi radians. And that will conclude our session on angles and radians and degrees. So hopefully you've taken good notes, and you have questions or any concerns you have written in the proper place, and we will conclude tomorrow. Have a great day.